So in continuation to our earlier session, so where we talked about how exactly one can create an object code format. So let us try to understand few of the existing formats. So this is the first session for understanding the ms-dos.com files. Now, when we do talk about this ms-dos.com files, these represent a simple executable file format used in MS-DOS operating system, like Microsoft Disk Operating System and similar environment. These files contain binary code and these are designed to be loaded and executable or executed directly in memory. Now let us have a kind of look maybe or overview with respect to this null object format in context of .com file format. Here, like it contains or accepts or works with a flat memory model. Okay, so they use a flat memory model. Now, like what happens is the loading starts from the fixed segment address. Generally, like it is said to be 100H. Fine. And program code starts executing directly from this location. Further, these files don't have like a header. Like for other executable formats like exe or a.out or elf32, say for a while, they may have their own headers, but .com files never contain a header or a metadata. They directly contain or entirely contain the raw machine code and data. I will be showing you an example at later stage. Now they do follow a simple structure. Now this is a single segment. Like this file is considered as containing only a single segment. This includes code, data, stack altogether. And that this simplicity makes this .com file kind of lightweight, okay, and easy to load. But again, like as we are talking about this null object format for DOS operating system, so there is a limit with respect to their size that they cannot go beyond 64 KB. This is maximum size of a single segment applied. Now, null object concept, this term refers to an absence of metadata or even the header structures. Now, this null aspect ensures that the file is containing only a contiguous block of bytes, now, which we interpret as an executable code. Now, there is nothing added as an embedding information, which may be used for relocation, debugging, and linking, which when we saw the object formats, rather how to design our own object format, that time we talked about relocation, debugging, and linking. Correct. So these .com files never have or contain information embedded inside them because the execution directly starts from the first byte. Okay. Now, from the execution perspective, execution environment of MS-DOS, the program loader initializes all registers like code segment, data segment, extra segment, even your instruction pointer or a program counter to point to the code, and like minimum execution environment is provided to it that doesn't have any fancy other parameters, and the instruction pointer or program counter starts from the first instruction which is specified into .com file. Now what it does actually, it helps the developers to handle everything on their own, including stack, segment setup, and so on. Now, when we do deal, we have to see contents of this .com. Okay, we need to understand that this .com contains raw machine code, which is not human readable. Correct. That is the reason. Like if at all you want to use some tools to inspect or disassemble the contents in a way where you can interpret these files, then let us take examples of some or methods for examining .com. Now you can make use of an hex editor, okay, to display this. Maybe like hex editor would be used to display the binary contents in hexadecimal form and ASCII formats, basically. Now, what is to be done? You can make use of hex editors like HXD, Hexprint, or Hexedit on Linux, probably. You open simply this .com file in that editor, whatever the editor that you used. You can examine the bytes. Okay, each byte corresponds to one machine instruction or probably the data. Correct. Other aspect to visualize or maybe to view contents which are not human readable directly, you have to make use of a disassembler. Now, generally, this disassembler would be used to translate machine code into human readable assembly instruction. Now, if I have to use a particular disassembler to see contents of .com, you can make use of, say, IDA freeware, which is a powerful disassembler used in IT industry. Ghidra, which is an open source reverse engineering tool. And as we used NASM, rather, this NDASM, which is NASM disassembler, like which is added always with NASM assembler, you can make use of it. So I will be showing you one example rather added there, which can be seen like how exactly we do use NASM disassembler to see contents of the object code. Now you even can make use of debugging simulators or emulators like DOSBox or debug rather. Okay, where you can use the DOSBox or an in an MS-DOS environment, you simply write debug and your file.com. You can make use of U to unassemble instructions as an parameter. This would be capital U. Capital D can be used even to view raw bytes. Okay, and if you want to trace the execution, you can make use of T. Okay, these would be the DOSBox commands with debug you can make use of. And so let us try to see how exactly the code looks like. Let us say I have typed this code per se. This is a simple .com program that I have added or .asm. Okay, now what it is containing? It is containing few instructions, which like this program is meant for displaying what you can say hello world program in on the DOS screen rather. Now here, like if you see what directly you may not see code segment, data segment or stack because this file only contains like when we do talk about object.com code generated, there is nothing called segment declaration in the source. There is nothing called relocation information and nothing is added as a debugging symbol as we pointed out earlier. So this code, the resultant code which results after translation to the .com form would be having contents which should fit entirely within 164 KB segment. Now, generally it contains, as we stated, code segment, data segment, and stack. Now, execution flow would be something different. Like now, when this .com is executed, okay, CPU starts from the entry point, like for example, 100. So you may see I have used an instruction called org100h, where like it will let the executable know that your .com file will be loaded from code segments 100h address. Now program would be handling its own stack and memory management internally would be done. So when we see like first statement org100h specifies that your file starts at 100 h address in memory. Now simply second instruction is DOS function which we are using for printing the string. Like we have to move that value with the AH comma 9. So this is DOS function for printing a string. Now you have to print the message. So you may see I have added a message variable with the DB hello world. Okay, like we have to load this address for printing purpose. So that's what we said, load effective address LEA DX comma MSG. Okay, this is meant for loading the addresses of the message. Then we will be using DOS interrupt 21H to print the string. And later, like if you see, I have added move AH comma 4CH. This would be a DOS function to terminate the program. And again, like we have to call interrupt 21H, call DOS interrupt to exit. Now here, like whatever the string that I have defined, you may see here, I have added the message string. It should be always terminated with dollar. Okay. Now, when this program is assembled using, say, NASM hello.asm, say for a while, dash f bin, the file format, and then like an object code form, you should write hello.com. Now, here, After assembling, the resulting file will contain only binary instruction corresponding to this program. Now you may see when I use file command with that com file generated after NASM, it shows me that COM executable for DOS. Now, as we stated earlier, like if you see, if you want to see contents, you can make use of NASM's disassembler. So I am using NASM disassembler for that .com. So you can see that the file contents are shown in some form, okay, which are like object code as well as the things added over there. Yes, you may see like it started from ultimately accordingly, whatever the way that you want to you want to start it with. Thank you.